Hello everyone, this is Shrawan sir, making maths simple for you. Welcome to my YouTube channel called Maths Academy. Today's topic is the principle of mathematical induction. Dear students, in the previous video, already we have proved the sum of the first n natural numbers by using the principle of mathematical induction. Now in this video, we are going to prove the second important formula of sequence and series, which is the sum of the squares of the first n natural numbers by using the principle of mathematical induction. Dear students, this question is frequently asked in examination in NEB Class 12 Mathematics. Here we go. Dear students, in order to prove any statement by using the principle of mathematical induction, at first we have to suppose the given statement as Pn. The statement involving natural number we suppose as Pn. So let's suppose let Pn be the given statement. Dear students, the first step of the principle of mathematical induction is we have to suppose the given statement. That means the problem or the formula which we have to prove is called a statement. We have to suppose the given statement as Pn. So at first we have to write down let Pn be the given statement. So this is the first step. Therefore, the given statement now we can write as the given statement we have supposed as Pn. Pn is such that 1 square plus 2 square plus 3 square plus n square is equal to n times n plus 1 times 2n plus 1 divided by 6. So dear students, we have to prove that the sum of the squares of the first n natural numbers is equal to n times n plus 1 times 2n plus 1 divided by 6. So this is our statement. So dear students, now according to the principle of mathematical induction, now we have to prove that the given statement is true for n equals 1. So dear students, in the previous video already we have discussed what is the principle of mathematical induction. So if you have not watched the previous video, please watch it so that you will get the basic concept of the principle of mathematical induction. So dear students, according to the rule of, or we can say the principle of mathematical induction, at first we have to prove that the given statement is true for n equals 1. Then by assuming, in the second step, assume that the given statement is true for n equals k. Then by assuming that the given statement is true for n equals k, we prove that the given statement is true for n equals k plus 1. So dear students, mainly there are 3 steps. In the first step, we have to prove that the given statement is true for n equals 1. Then by assuming that the given statement is true for n is equal to k, we prove that the statement is also true for n equals k plus 1. Then we write that according to the principle of mathematical induction, at last we write on the conclusion, we write that the given statement is true for all the natural numbers belongs to n. So these are the main three steps we have to keep in the mind. So let's start. Dear students, the first step is now we have to show that the given statement is true for n equals 1. When n equals 1, that means if we take the number of term 1, then we prove that the value of LHS is equal to RHS. So let's take LHS. So when n is equal to 1, that means if we take the number of term 1, then in LHS, left hand side of this statement, we have the term 1 square. So dear students, if we take the value of n equals 1, that means if we take the number of terms 1 of this given series, then in LHS we get 1 square. 1 square means 1 times 1, which is equal to 1. Dear students, now we put the value of n equals 1 in the right hand side also. So let's take RHS. Dear students, in RHS, that means in the right hand side, we have n times n plus 1 times 2n plus 1 over 6. Dear students, now we put the value of n 1. That means we'll replace the value of n, we'll replace n with 1. So let's put the value of n 1. Dear students, if we put the value of n 1, then we have to put the value of n equals 1. We have put the value of n 1. Here also we have put the value of n 1. Then we get 2 times 1 plus 1. Then after calculation, 1 plus 1 means 2. 2 times 1 means 1. 2 times 1 means 2. 2 plus 1 we get 3. Now 3 2s are 6. 6 1s are 6. 6 over 6. So if we cancel, that means if we divide 6 by 6, then we get 1. So dear students, we see that when we take the value of n equals 1, then the value of LHS and the value of RHS both are equal. That means according to the principle of mathematical induction, the given statement is true for n equals 1. Dear students, now in the second step, we assume that the given statement is true for n equals k. So let's go to the next page now. So dear students, our statement is Pn 1 square plus 2 square plus 3 square plus n square equals n times n times n plus 1 to n plus 1 divided by 6. So dear students, in the previous page already we have proved that the given statement, that means Pn, is true for n equals to 1, because we have got the value of LHS and RHS both equal. So dear students, we have to write down the conclusion. It shows that in every step we have to write down the conclusion. It shows that Pn is true for n equals 1, because we have got the value of LHS and RHS equal. Dear students, now let's move to the second page of this problem. So dear students, already we have proved that the given statement is true for n equals to 1. Now we have to assume that the given statement is true for n equals k. So I have copied the given statement from the previous page. So let's assume that. Let us assume that, or we can write, let us suppose that. Let us assume that Pn, that means given statement, let us assume that Pn is true for n equals k, where k is a natural number. This means if we assume that the given statement Pn is true for n equals k, then the given statement will change in the form of, that means we have to put the value of n equals k in the given statement. Then our statement will be 1 square plus 2 square plus 3 square plus dot 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 k square. So dear students, we put the value of n equals k in the given statement. So we have to put the value of n k. Here also we have to put the value of n k. Then we get k square equals k times k plus 1 2k plus 1 divided by 6. So dear students, we have to replace n with k both on LHS and RHS. So when we put the value of n k in the given statement, then it will be k, putting the value of n k, that means we get k plus 1, and again putting the value of n k, then we get 2k plus 1 divided by 6. And let us suppose this as equation I. So dear students, in the second step, we have to assume that the given statement is true for n equals k, where k is a natural number. So simply we have to put the value of n k on both sides of the given statement, and we suppose this as equation 1. So dear students, now according to the principle of mathematical induction, we assume that the given statement is true for n equals to k, and by supposing this, we prove that the given statement is true for n equals k plus 1. So dear students, the third step is, now we show that Pn, that means our given statement, is true for n equals k plus 1. When Pn is true for n equals to k, when Pn is true for n equals k. So dear students, this is the third step. Now we show that Pn, that means our given statement, is true for n equals k plus 1 when Pn is true for n equals k. That means if Pk is true, we have already supposed that Pk is true. If Pk is true, then we have to show that the statement is true for n equals k plus 1. That means we have to prove that Pk plus 1 is also true. So dear students, now let's put the value of n k plus 1 on both sides of the given statement. Then the statement will be in the form of, simply we put the value of n k plus 1 in the place of n. Other terms will be as it is. So dear students, already we have assumed that our statement is true for n equals to k. So simply we'll copy and paste. We'll write down the terms from 1 to k square, that means kth term. Dear students, now we put the value of n k plus 1 in our given statement because we have added one extra term. That means if we put the value of n k plus 1 in the given statement, then we'll get k plus 1 whole square. So we have put the value of n k plus 1. So if we put the value of n k plus 1 in the place of n square, then we get k plus 1 square, which is k plus 1th term. So dear students, we have to put the value of n k plus 1 on the right hand side also. So if we put value of n k plus 1, if we put value of n k plus 1, then we get k plus 1. Again, if we put value of n k plus 1, then plus 1 will be 2. That means we get k plus 2. Dear students, if we put the value of n k plus 1, then we get 2 times k plus 1 plus 1. So dear students, divided by 6. So dear students, after further simplification, we get k plus 1 times k plus 2. So if we open this bracket, that means if we multiply k plus 1 by 2, then we get 2k plus 2 ones are 2, and if we add 2 with 1, then we get 3. So dear students, by putting the value of n k plus 1, dear students, by putting the value of n k plus 1 in the given statement, we have got 1 square plus 2 square plus 3 square plus k square plus k plus 1 whole square equals k plus 1, k plus 2, 2k plus 3 divided by 6. So dear students, now we have to prove that this statement is true by showing LHS equal to RHS. So let's now go to the next page. Dear students, now we have to take LHS. So in LHS, we have 1 square plus 2 square plus 3 square plus k plus 1 whole square. So let's take LHS. 1 square plus 2 square plus 3 square plus k square, and the last term is k plus 1 whole square. So dear students, by taking LHS, we have to prove that the sum of the terms of LHS will be equal to k plus 1 times k plus 2 times 2k plus 3 divided by 6. So already we have taken LHS. So dear students, we know that the sum of the terms from up to kth term, we have already got k times k plus 1 2k plus 1 divided by 6. So now we are going to use the sum of the terms up to kth term in the LHS. So dear students, so already we know that the sum from the first term to kth term is k plus 1, it is k plus 1, 2k plus 1 divided by 6, 2k plus 1 divided by 6, plus the last term we keep as it is. So the reason is by 1. So dear students, the sum from the first term to kth term we have k times k plus 1 2k plus 1 divided by 6, which is from the first equation. We have assumed that the statement is true for n equals to k. So we have put the value from I. So already we have put the value that the sum of the terms to kth term is k plus 1 2k plus 1 divided by 6. So dear students, by putting the value of the sum of the terms from 1 to kth term by 1, we have got k times k plus 1 2k plus 1 divided by 6, and this last term keeping as it is because we have added one extra term. Dear students, now by simplifying this, we have to get the RHS. Now let's take the LCM. So before taking LCM, we can take the term k plus 1 common. Dear students, so first let us take k plus 1 common. See, if we take k plus 1 and k plus 1 common, then the remaining terms will be k times 2k plus 1, k times 2k plus 1 divided by 6 plus k plus 1. So dear students, now let's take the LCM. So dear students, now if we take LCM 6, then k times 2k we get 2k square, k times 1 we get k, this term will be as it is, and we multiply k plus 1 by 6. So 6 times k plus 1, keeping k plus 1 as it is. So dear students, if we open the bracket with 6, then we get 6 times k plus 6 1s are 6. Dear students, so by adding 6k and k, we have got 7k, and keeping all the terms as it is. Now we can factorize this expression by first into last method. 6 2s are 12, the product we need 12, and the sum we need 7. So we can easily break down. Distance 7k we can write as 4k plus 3k, because 4 plus 3 we get 7, and 4 3s are we get 12. So this is very simple calculation, you can do it easily. Distance from the first two terms, let us take 2k common. So if we take 2k common from the first two terms, then the remaining term will be k plus 2 2s are 4, plus if we take 3 common, then we get so dear students, if we take 3 common, then we get k plus 3 to the 6. Dear students, so let's do further calculation. K plus 2 we can take common, and 2k plus 3 will be as it is, or we can say the remaining term. So dear students, the sum of the terms of LHS, we have got k plus 1 times k plus 2 times 2k plus 3 divided by 6. k plus 1, k plus 2, 2k plus 3 divided by 6. So dear students, we have got the sum of the terms of LHS equal to RHS. So dear students, now we can say that the given statement is true for n equals to k plus 1. It shows that Pn is true for n equals k plus 1 when pk is true. So dear students, at last we have to write down the conclusion. We have shown in the first step, we have shown the given statement Pn is true for n equals to 1. Dear students, in the first step, we have proved that the given statement is true for n equals to 1 by showing LHS equals to RHS. In the second step, we have assumed that our statement is true for n equals to k. Then by supposing that the given statement is true for n equals to k, we have proved that the statement is true for n equals to k plus 1 by showing LHS equal to RHS. Dear students, in the third step, we have proved that the given statement is true for n equals to k plus 1 when it is true for n equals to k. Now at the end of this solution, we have to write down the given statement is true for all the natural numbers n belongs to n. n belongs to natural number. So at last we have to write down the conclusion. Dear students, at last we have to write down the conclusion. Hence, by the principle of, we have to write down the statement of the principle of mathematical induction. Hence, by the principle of mathematical induction, the given statement is true for all the natural numbers n belongs to n. All the natural numbers n belongs to n. Hence, it is proved. So dear students, by using the principle of mathematical induction, we can prove all the formula of sequence and series by very easy process. So dear students, in this video we have proved one of the most important formula, which is the sum of the squares of first n natural numbers by using the principle of mathematical induction. So dear students, I hope that you have understood how to prove by using the principle of mathematical induction. Thanks for watching this video. Next time we'll meet with a new content. Till then, bye. Have a nice day. Thank you.